One way to solve a quadratic equation is to square root each side of the equation. And so we would square root each side as I've done here. And the common mistake is for people to say, oh, square root in the left leaves me x, and square root in the right leaves me the square root of 10. However, technically there's supposed to be two answers to this problem, not just one. What they don't realize or they forget is when you square root x squared, the answer is the absolute value of x, because whatever comes out of a square root must be positive. And it's the removal of that absolute value that gives you the plus or minus that's going to be over on the other side. Some people just say, you know what, whenever I square root both sides, I remember to put that plus or minus sign. But if you forget it, technically you've lost half your answer. The safest way to do this problem is to say, hey, it's quadratic, I'm going to set it equal to 0, and to subtract the 10 on each side in this case, and then do the difference of two squares. But that's kind of strange because 10 isn't a square of an integer. We have to take the square root of 10 as we're doing that process, but you still get to the solution set x is equal to plus or minus the square root of 10. Please do not forget that absolute value sign. For number 2, when we square root each side, we get x is equal to plus or minus the square root of 48. And we need to simplify that 48. You could go 6 times 8, 12 times 4, but I choose 16 times 3 because I can instantly see that I've got a 4 squared inside that 16. And so I know that my solution set will be x equals plus or minus 4 root 3. When we have x squared equals a negative, that tells you we're going to end up having imaginary solutions. Square rooting each side gives us x is equal to plus or minus the square root of negative 20. And that negative 20 is going to break down into a 4 times 5, and you know that the square root of 4 is 2. So we will have x is equal to plus or minus 2 root 5i, or as we commonly like to write it, plus or minus 2i root 5. Technically, this first one is more correct because you have bi with a coefficient written in front of the I. However, some of us tend to go wee with our little radical symbol and have that I ending up inside, which is not really supposed to be the case. And so it's safer sometimes to put that I out in front of the radical. Now I have a matching problem, and we're looking at x squared equals k, and we've got 3 different cases. K can be positive, negative, or 0. We know that when k is negative, x squared equals negative, then you're going to have 2 imaginary or complex solutions. So that goes with number 3 right there. Then we've got 2 other cases. When you have x squared equals 0 in this third case, then there's only one solution. X is equal to 0, so our matching choice is number 1. When k is positive, x squared equals k tells us that we're going to have 2 real solutions. So that's just another way of looking at this type of problem. Now let's add some extra steps into this problem. This one is just crying out to be square rooted because you have a completed square already isolated on the left hand side. When you square root the left, you get t plus 5. Now technically that is inside absolute values, but we don't like to write those absolute values down, so I'm going to instead write this as plus or minus the square root of negative 18. That plus or minus takes the place of the absolute values. Then I'm going to want to simplify this square root of 18. I know that I've got a 9 times 2 there, so I've got t plus 5 is equal to plus or minus 3i square roots of 2. At this point, we need to subtract 5 on each side, and we're going to have t is equal to negative 5 plus or minus 3i root 2. Now, if you are using an online homework system, it may request that you write this as 2 separate solutions, and it may request them to be in a plus bi form. So if that's the case, you would be entering negative 5 plus 3 root 2, then I. Be careful that the I does not go inside the radical. comma, the other solution, negative 5 minus 3 root 2i. You can play around with putting the I in front of the radical if you wish, but do so at your own risk because I don't know which homework system you may be using. In order to square root each side, we need to first isolate the radical by itself, not the radical, the square by itself. So we want to subtract that 7/4 on each side. This leaves us with x minus 3/4 quantity squared equals negative 7/4. Then, when we square root each side of this equation, on the left side we will have x minus 3/4. On the right side, do not forget that plus or minus symbol. The square root of 4 is a 2 down in the denominator. And now we've got to square root that negative 7, which gives us I root 7. Now what we need to do is add 3/4 to both sides. Well, I would sure wish I had a common denominator here, so I'm going to rewrite this 1/2 as 2/4 so that I can have a common denominator. This would give me x is equal to 3/4, then plus or minus 2i root 7. And I think you can agree that the answer looks a little bit nice in this form, which we're used to from using the quadratic formula instead of two separate fractions. However, do know this is not technically an a plus or minus bi form. You might have other teachers or online systems or books that insist that you write this in a plus or minus bi form, which would be 3/4 plus or minus, well, 2 root 7 over 4 is going to reduce, as you know, to root 7 over 2i. And then we physically see a plus or minus bi in that form. So it just depends upon your teacher and which form they're asking for this to be in. For number 7, before we can square root each side, we need to first subtract the 7 and divide by 3. I still know this is one of those problems where I want to square root each side because my variable is trapped inside of this quantity squared and there's no other occurrences of the variable anywhere else. So let's begin by subtracting 7 on each side. That leaves us with 3 times t minus 1 squared is equal to 5. And unfortunately, when we divide by 3, we're going to have to create a fraction. Now I chose to go with the messiest possible problem here so that if you can handle this problem, you can handle anything. Now we want to square root each side. On the left, we have t minus 1. On the right, we're not going to forget that plus or minus symbol, but we've got plus or minus the square root of 5/3. We can't have that radical in the denominator, so we will rationalize the denominator by multiplying by root 3 over root 3. Now we've got t minus 1 is equal to plus or minus the square root of 15 over 3. Okay, well, we want to add 1 to each side. Well, when I go to add 1 to each side, I'm going to add it on the right as 3/3. That way I can write this as t equals 3 plus or minus the square root of 15 all over 3 with that common denominator. Note that I did have the option, if I wanted to, of writing my solution as t equals 1 plus or minus root 15 over 3, but just make sure if you write it that way that only the root 15 is over the 3 and not the 1. We are used to seeing our answers in this combined form because we're so used to using the quadratic formula.